5. And Bill is very stingy, he always gives below 3. So if I want to compare their ratings, like I told you, in the similarity based or in the collaborative based, we compare rating behavior of people. Now if Sabre is very generous and Chris is very stingy. He always goes to a restaurant, he says, I'm not going to give anybody less than 4. I give everybody at least 4. And Christopher says, I don't give people good rating, I give less than 3. So how do I compare 5 for him or 4.5 for him and 3 for him? What I can do is, one of the techniques that you can do is you see how much it is different from the baseline. So rather than comparing actual numbers, you compare how much their rating is different from their baseline prediction. This approach is called predicting the bias approach. Because 4 for one person may not mean 4 for the other person, because 4 for one person may be really high and 4 for one person may be really low. So again, it's not that this is asked in the exam or anything, but this is just to remind you that there is such a technique. Finally, the last thing that we looked at, so there will be a question on similarity, hopefully you can get that. The last approach that we looked at was something called latent factor approach. Latent factor is also called the matrix factorization approach. And what we did in the last approach, and some of you are taking big data course, and for the big data course you might have you studied matrix factorization approach?
Yeah.
For recommender system?
Yep.
What does that approach do? So you take a matrix, which is sometimes called the utility matrix. The utility matrix is users along the rows and items along the columns. User item matrix, which is called the utility matrix. And the utility matrix is a very sparse matrix, right? Why? Because very few people rate the items they buy, and very few people are actually going to buy all the items in my store. It's impossible for somebody to buy all the items at Amazon to try to buy that. So what we can do is we take this and we represent it as the product of two denser and smaller matrices. The one matrix is called U by K. The second matrix is called K by I matrix, or not called, it is the dimension of that is K by I. So you represent this matrix as a product of two matrices. These are called factor matrices, and these tell you about the preferences of user and item. So this is an approach that can be done, that is currently the most popular approach, which is called matrix factorization approach. Now there are two ways in which you can factorize this matrix. We don't want to go into the math of it, but one of the techniques is called ALS technique. Heard of it? It's called alternating least square technique. The second technique is called SVD technique, singular value decomposition. Now for those that are really into linear algebra and math, you can go into the details, but I'll skip you that ordeal. I will not go there. But there are two techniques in which you can take a matrix and split it up into smaller or dense factor matrices. That's ALS, SVD, and that is also a technique that is used for filling in the missing values. So that is called latent factor approach, which is something like this. This is an example of matrix factorization approach. In this case, there are three factors. The factors we have seen have a meaning. It's up to you to unearth the meaning of the factors, but the factors have a meaning behind them. So this is this. So again, my next question is, which of the following are baseline algorithms available in surprise library of Python? SVD and ALS, these are the two algorithms available for matrix factorization. Okay, after studying this recommender system topic, and we had done a lab on it, now I'm not going to ask you too many questions in Python code, so I'm not going to ask you questions from the lab, so it's not like we're going to ask you Python questions. So focus on the conceptual part of it for most things. So no need to memorize the lab or no need to remember the commands of the lab, but focus on conceptual things. The last thing that we talked about was frequent pattern mining. In frequent pattern mining, you have to understand some basic questions can be asked about support confidence. So there will be questions, very simple questions on support and confidence of rules. Support simply means the frequency. For example, I can give you this data. This data is, there are transactions and each transaction has certain items that people have bought. Now what I could say is, find the support of item E. Support of item E simply means, out of these whatever number of items that there are 10 items. Out of these 10, how many items contain E? So you can see the support of E is 0.8, which is 8 out of 10 contain the item E. How many contain BD? So it's a very simple question, and it's easy for me because I can make a question, and easy for you, you can answer it, which is find the support of the item set. So this is how many transactions contain E. How many transactions contain B and D both? So you can see 20% of the transactions contain B and D. So support of an item is how many transactions contain that item. It's very simple to understand. Hopefully you are good with that. The confidence is generally associated with the rule. Confidence, and so keep this here, keep this into account. Now, if I propose a rule, BD gives E, then the confidence for this rule means what is the probability of buying E given that I buy B and D both? Which is, if left hand side, what is the probability of right hand side? That is called the confidence of a rule. Which is, given that somebody has bought milk, what's the probability that they will buy cheese? Or given somebody has watched Jurassic Park, what's the probability that they will watch Back to the Future? Something like that. So how do you find, so if you can tell me the answer, I'm going to be impressed. So here is the answer right here, which is, you count how many cases are there with BDE, divide that by how many cases are there with B and D. That is called the confidence of a rule. Nice. So simply, and you can say BDE is 100%. So if somebody buys BD, then they buy E, that's like 100%. The confidence of E gives BD is not the same. So if it's like, I could ask you, what's the probability that somebody who takes 4371, given they take 4371, what's the probability that they take 4372? That is called confidence of the rule. Confidence means, the way you calculate it is simply like I told you, find the support of BDE divided by the support of BD. That is going to give you the confidence of a rule. Okay, so there can be questions on support and confidence. Very simple questions that you could be asked. Now, after that, we had done something called frequent pattern mining. In frequent pattern mining, we had done two algorithms for frequent pattern mining. The two algorithms that we had done for frequent pattern mining, which is, one of the ways is to manually sit there and count how many cases are there with this and this. There are two automated algorithms. One algorithm is called the a priori algorithm. The second algorithm is called the FP growth tree or FP tree algorithm. Both of these can automatically generate a lot of data, and they can generate confidence rules, like we were doing in class. We were using a library and we were saying that if somebody watches this movie, they watch this movie, and so on. So we had done a priori algorithm and FP growth algorithm. Let me briefly talk to you about what these algorithms are and how they can generate a lot of confidence rule. Now what you do is, suppose you are given this data set. This is a data set of transactions. Like, there are 10 transactions and there are items that people have bought in each transaction. So there are 10 items, 10 transactions, each has different items. So what you do is, the first thing, and we are talking about a priori algorithm, is first thing is you write their sorted frequency of one item set. You take singular items, which is one item, you write their sorted frequency. The sort order is pretty important, and I learned this, I knew this algorithm, but throughout this class I learned it more myself. So the sort order is pretty important. In case there is a tie, you have to sort it in lexicographical order, and you have to keep that order intact, which is B comes before D. So since there is a tie in then, I'm going to keep this order, and this is going to be my order. This is called one item sets. One item set means item set of length 1. So I'm going to keep this thing right here. So this is one item set. Now what do? Is I generate candidates of item set 2. So if there is something that is not frequent, I'm going to prune it. Suppose there was an item X, it was present only in one of the transactions. So I would prune that item. Prune means getting rid of it. So I would prune that. Now what do is you join the data set to itself to get candidate item sets of length 2. How do you join it with itself? You say EA, EB, ED. You do such things. You join it with itself and you do the frequency count. Here, since there is nothing, generally you keep the prefix constant, but for item sets of length 1, you simply do a join and you find which item sets are, you find all the item sets. So this is called self join, and you get generate C2. C2 is candidates of length 2. Just because something is a candidate does not mean it is frequent. You actually write it down and then you get rid of anything that is less than support 3. Why? Because my minimum support is 3. So you need to get rid of anything that is not frequent. So which is something you can prune? This is something I can prune. This is something I can prune. So I prune these two. Unfortunately, at this stage you have to do this manually. So a priori algorithm requires you to manually do it for two item sets, item set of length 2, and get rid of anything. So after you have done this, you end up with this situation. So these are F2s. F2 means frequent items of length 2. Now here is where it gets interesting. When you do C3, candidate generation of length 3, you can say that I'm gonna combine these two. I can self-join these two. Why I can self-join these two is they have the same prefix. Since they have the same prefix, I can join these two to generate A, B, C. Similarly, I can self-join this to this and I can generate A, B, D. Similarly, I can self join AC to AD to say ACD. Similarly, BC to BE, I can generate this. Now, if you keep everything in a sorted order, it's gonna help you. Otherwise, you are gonna get way too many such things, and you might get some things that are not useful also. So keep them in sorted order. Notice that we are keeping the things in a sorted order. Sorted means A comes before B. Hopefully this is what A comes before B. Why is A B? Not because it is lexicographical, because this is the sort order. Similarly, D comes before C. There is no DC, but I'm keeping it in a sorted order. So if, yes.
Shouldn't E come before C, like the last one?
Yes. So again, E should come before C. So if you follow this order, you will get just less number of candidate generations. If you don't follow it, you might get C, E, E, C. So yeah, there is some typo here, which I also learned in this class, that I have some typos, and so if you should keep things in in the sort order. The sort order should be established before doing anything, and you should keep things in the sort order. So he is right. We should keep things, and I checked in the exam. There are no such mistakes. Things are kept in a sort order. In fact, there are simple questions. They are not difficult questions. Now, here is one thing that I want you to realize, which is a priori property. A priori property, which I should emphasize, is BD is not frequent. See this? Now, anything that contains BD cannot be frequent. So, since BD is not frequent, EBD cannot be frequent, for example. Why? Because BD is not frequent. So CBD cannot be frequent because EBD is not frequent. That is called the a priori property. So what you do is you can look at, when you are looking at item sets of length 3. So when you are looking at item sets of length 3, like I told you, you can join A, B, C. So when you look at this, you can say, I don't have to do a count of ABD. Why don't I have to do a count of ABD? Because B and D is not frequent. Since BD is not frequent, ABD cannot be frequent. So BD is not frequent, like I told you. BD is not frequent. That means this is not frequent. Similarly, I can say ACD, I don't have to do a count because ACD cannot be frequent. Because CD is not frequent. So that is called the a priori property. So using the a priori property, I can do that. Now, after doing that, you can do a self join again. Now, there is a typo here which I would like to point out. These two should never have been joined. This join, if you follow the logic that I have discovered, then in order for me to join these two, A, B, E and A, D, E, they should have the same prefix. They don't have the same prefix. Let's see.
Professor, so to clarify, sort order is alphabetical or in terms of frequency?
Frequency and then alphabetical. So first sort order. So ideally this should be written as E, A, B. This is how this should be written. And this should be written as E, A, D. So if I was following my convention, which I did not, and I apologize for that, then I should be able to join this and I should be able to form EABD. because it helps. And so I'm gonna have to redo my slides, but I promise you in the exam they are in correct order. But you have to be sure that you need to keep things in the sort order. So this is where we had some problem in this, but hopefully you are able to understand. The sort order is very important. Now this is the uh, FP, no, this is the a priori algorithm. Now a priori algorithm is longer because it requires you to generate candidates and then prune them. Pruning means getting rid of them. So generating and then pruning. So this is called candidate generation step. Candidate generation, you generate candidates C3 and then you prune them to get F3. So it is a little bit inefficient. The better or the more efficient way is to do something called FP tree algorithm. What happens in FP tree? FP tree also works by the same way. You establish a sort order. So in this one, I'm promising you we are going to follow the sort order. You have to follow the sort order. So you make a sort order, this, and then you list everything in your data in a sorted order. So here is what I have done. You list everything in a sorted order because you have to. Without it, it's not going to work. So you list everything in a sorted order. Hopefully, you E, A, B, D, C is the sorted order. And you will see that everything is listed in a sorted order here. E, A, D, E, A, B, C, E, S. So everything is listed in a sorted order here. You cannot proceed in FP tree without sorted order. So you proceed, you put everything in a sorted order. Now what do you do then is you start constructing a prefix tree. Prefix tree means you start at the root and you say E, A, D, C. This pattern, how many times this pattern occurs. So you start constructing the tree. The way you're going to construct the tree is you're going to say, okay, let's start with item 1. Let's start with root and E, A, D. E1, A1, D1. The second item set, so this is, I'm done with this. The second one will be EA, they share the same prefix. So E will become 2, A will become 2, but they don't have D. So they have B and C. So I'm going to include B and I'm going to include C, B, C. So I'm done with the second one. The third one has EABD. So what will be the count of E now?
3.
3. E, A will become this one and this one will become 2 and there will be a B to D node. 1. So I'm done with this one. And then EADC. So EADC. So E will become 4, 4, 4.
2.
D will become 2. And below D there will be a C. C will become 1. So I'm going to construct a prefix tree. This is called a prefix tree or a suffix tree, whatever you want to call it, generally prefix tree. So I'm going to construct a tree like this. So I'm going to keep constructing this tree and that will be my tree construction step. So this will be my tree that I'm going to construct. So starting from the root, I'm going to construct a tree. And this will be my FP tree or frequent pattern tree. That is what is called, frequent pattern tree. Now what you do after that is then you start mining this tree. You can say you start at the bottom, you start with C and you start mining the patterns for C. So you can see, okay, let me start with C and EAD1. So you are going to get EAD1. Then you are going to get EAB1. So you start with C because C is the lowest level. You start with C1 and then you start with C here. You're going to say EAB. So EAD1, EAB1. So EAD1, EAB1 and you're going to keep writing the patterns like this. And then you are going to take whatever is common. So you are going to say that this is one branch of the tree. You cannot combine across branches. So you will keep the branches separate. So you will see, okay, across this, what is common between the three? you will see that E is common 3 times, A is common 2 times, B is common 2 times, and D is there only 1 time. So you are going to write how many times they occur. You are going to count the frequency here. This is called conditional FP tree. So you are going to do this. Similarly, here you are going to say, in this case, E occurs 3, 4, 5. E occurs 5 times. A occurs 4 times. B occurs 2 times. So you are going to write down the frequency, how many times each occurs, and using this frequency, which is called conditional pattern tree, conditional FP tree, you are going to say, since this is the pattern, you are going to generate how many possible combinations. So you're going to say E A B C, E A B C, E A B, sorry, EC3, sorry, E and C, you can combine EC. A and C, you can combine AC. B and C, you can combine. So you're going to combine these are called the prefixes. So you can combine the prefixes and you can generate something like this. And these will be the final patterns that will be generated. Now there are a lot of interesting videos about this which I suggest are you can watch. So there are videos which are
Subscribe, Professor.
So there are a lot of interesting things where you can look at FP growth. Now, how many of you have been taught FP tree as part of data structures and algorithms? Suffix tree, prefix tree.
Howard.
You have been taught something like this?
Data
Suffix tree?
structures.
Okay. What tree? Prefix tree. Of course. So prefix tree. So these are called prefix tree, suffix tree, and they can generate tree items. Now, luckily, we have libraries that do that for us. So the libraries generate all these patterns, and these are the patterns that can be generated. So, any questions about this? Yes.
So why isn't there a frequent pattern that's E A B B C? Or do I generate?
So we have EAB.
Or in the first
Which one are you talking about?
So in the initial FP tree,
Okay.
we have E A B B.
Yeah.
Yeah, when we generate.
Because sorry, D is less than the minimum support.
Isn't E A also? Or do we have?
So here, since